first thing, if we look here at problem number 1 in 2.4, it says that the following is data for the first and second quiz scores for 8 students in a class. Plot the points and then sketch a line that fits the data. Now, we're not going to do this by hand. We're going to use technology. So we want to do a scatter plot. And basically, we're trying to see if this scatter plot is going to follow a linear trend. Is there something about the first and the second quiz scores that one predicts the other? So here's the first thing that we're going to do on your calculators. We need to clear the list that we're going to put this data into. Now, here's the easiest way to clear your list. Everybody with me?
Yeah.
I'm going to go to second and the plus sign. Second plus sign. And number 4 says clear all lists. So I'm going to hit 4. It says clear all lists, and I hit enter, and it says done. That's the fastest way to clear your list. Now, hey, stay with me. If you have a question or you get lost, you need to tell me right then. Okay, now we're going to go put our quiz 1 and quiz 2 scores in a list. To get to list, we go to stat. Stat is right up here. Notice when I hit the key, it turns red, so you'll know the last key I just hit. Stat. We want to edit, so we want number 1. And here's my list. Check and see if your lists are named L1, L2. If not, I can come and we can fix that.
I know, but like, it's so strict. Like, it has to be a perfect pass. Like, it literally has to be a perfect pass. And that's hard. Just shoot it. The answer is no.
Everyone's list okay. Okay, let's put in. Hey, don't make me hush every like 2 seconds here. Let's put the first quiz scores into list 1. So all I need to do is be right here where that is highlighted, and I'm going to type in 11 and then hit enter. And I'm just going to keep going down the line. 20 enter. 24, and just keep going. Go ahead, use your arrow keys when you're done. Go over to list 2, and let's type in the second quiz scores. Mrs. Doyle.
Maybe you think that he is your boyfriend. You expect me to know how to do
Is that one whole area? Can you read the 4 areas again? No. Yes. Maybe. I would do the last 3 if you were gonna do. Bye-bye. Okay. great.
Oh, we don't have safety glasses. We don't have safety glasses.
You ready? Wait, you tell me which glasses. That's what I need.
Yeah, because he has like 50.
Okay, now we're ready to do our scatter plot. Now, all graphing occurs at the top of the calculator and as well as doing like scatter plots. So we know y equals is where we would go to graph functions, but if we want to graph like scatter plots or histograms, that all takes place up here in stat plot, which is right above y equals. So I have to hit second y equals. Second y equals, and that gets me into stat plot. And then I just want to, you might note here and see if all these plots are turned off. We're only going to use plot 1. So you might note that if you've got a bunch of plots turned on. I'm just going to pick number 1. Here's how, go in, hey, Rachel, go ahead and go into number 1 and I'll show you how to turn them off. It'll be easier from here. Okay, if you have plot 2 or 3 highlighted, if plot 2 or 3 are highlighted, you can use your arrow key and you can go up here and then hit enter and it will unhighlight it. That's the fastest way to turn plot 2 and 3 off. Now we want to turn plot 1 on, so if it wasn't turned on, go ahead and turn that plot on. Use your arrow keys, and then we want to select our first option, which is a scatter plot. We want it to draw from list 1 and list 2, because that's where we put our quiz scores. If those are not list 1 and list 2, let me know and I'll help you get them changed to where they are. You all good?
Yeah.
Okay, you gotta tell me now. Okay, now we're ready to graph our scatter plot. To do this, we need to do a zoom that will zoom to the data in these lists, and it's zoom 9, zoom stat is what it's called. So I'm gonna go up to my zoom, and if you want to arrow down so you can see it, what it looks like, you want to go to zoom 9, zoom stat, and hit enter.
Nice.
Now, here's what happened on mine. I have some equation, a function also graphing. So I'm going to go to y equals and get these cleared out. So if you are also graphing other things, you can get those cleared out. Now I should just be able to hit graph and go to my scatter plot. Anyone need help? This is your chance if you need help. Okay, now when we look at this, does it appear that there's a linear relationship between quiz 1 and quiz 2?
Yeah, pretty much.
Who made the best fit line?
So that would be linear. If we think we could fit a line to this. See, you can have data that when you do a scatter plot might look quadratic. It might look like a parabola. We can have data that when we do this scatter plot, hey, everyone listen. Like have your pay no attention to this. Ellie, put your computer away. Phones away, or I'll take them. I'll get grumpy and I'll take your phone for the rest of the day. Because I don't have anything to do during my time period. I'll text and tweet, Snapchat.
Yo, I'm total
For you.
sad for Snap's
Okay.
kid's phone.
See, data doesn't just have to follow. You've probably only dealt with scatter plots and line of best fit, but it doesn't have to be. It can be exponential, it can be quadratic, it can be even sinusoidal, which sinusoidal is what we'll deal with second semester when we do sine and cosines. So what we're going to do now is we're going to go ahead and see what line would fit to this data. And we're gonna let the calculator do it for us. So the next thing we need to do is we need to go to stat again, stat,
Yeah.
stat. See my red key highlighted?
Yeah.
And then we're gonna use the arrow key and go over to calculate. Down here at number 4, it tells us that we can do what we call a linear regression line. A linear regression line is going to fit the best line to this data, minimizing what we call residuals. So we're going to pick number 4. And this next step, it kind of depends on the operating system of your calculator, what is showing up right now. So if you have an older operating system, this might not show up, and I can come and show you what we need to do. Okay, I'll be there next. So if yours looks like this though, hey, if it looks like this, we should have X list be L1, L2, just leave all this, and we're just gonna arrow down to calculate. And then enter, and you're gonna have to enter, no, you don't even have to, we're gonna have to do something else though, because mine's not showing everything up. Yours actually is default, L1, L2. So as long as you
I'm running.
I can't get it.
Yeah, I'm running Windows XP on my calculator.
I'm running Excel.
I'm running. I'm running. I'm running Lollipop.
I want to move out.
Now, okay, we need to get some of your calculators right now. After this, also say R and R squared.
Yeah, they do.
No.
We want all of our calculators to say that. Okay, I need you to listen. Unless you want to figure all this out on your own.
Huh?
You made me yell on my recording.
Oh, sorry.
Yeah.
Okay, we need all of the calculators to have after this an R and an R squared, because those are very important to help us know if a line is a good fit. And I'm going to explain what they mean. But a lot of our calculators do not show them right now. So I need to show you the steps to get it to where they do. So we are going to go to our catalog. Catalog is right above 0. I didn't want to hit 0. I didn't even touch 0. I want to go to the blue catalog. So I'm going to hit second and 0. And that takes me to the catalog. Now we're going to scroll down until we get to the D's. And we want to find diagnostic on. Diagnostic on.
What are we looking for?
Diagnostic on is what we're looking for in the D's. You can probably hit like alpha D and it'll take you to them. I can't do it on the computer.
Diagnostic on. You said
My brother's jelly.
Okay. Diagnostic on. You guys find it?
Yeah.
Once you find it, hit enter,
Bunch of metabolic.
and you'll have to hit enter one more time, and I've got an error because of that darn zero in front. There we go. It should say done.
Good.
I don't know, yours is already showing at least R. This one may not do it. So,
That's all I'm good at. Although I was playing basketball. I think I moved my sport Nathan, I was laughing. It's like I just kept taking a step like
I remember one time
That would pay for.
during like freshman, no, it was right before like basketball or something. Yeah, and I just kept missing. I made like 7, and then everyone's like, "That's because of me." Are you sure it's not
Yeah.
that? Hey, yo, I do bump up.
So like, how did you just learn to shoot? It's like,
Well, see, when I was little, I didn't have a coach that coached me on shooting.
so you were just
So,
like,
no, it was just, it used to be this. And then I was like,
Okay.
yeah, you need to work on shooting.
Now,
So I go.
we're gonna go back. Everyone hit clear on your screen.
So then.
Clear. So we have a blank screen. Clear. Now, let's go back and let's calculate that line again. So we're gonna go to stat, calculate, and we want linear regression, which on most calculators is number 4.
Whoa.
And then we're going to go calculate it. And this time, it should give you R and R squared.
yeah, I'm not next to anymore, dog.
Now, in your packet, below this problem, wherever you have a little tiny bit of room, we're gonna write. Shh. We're gonna write the equation of this regression line. Now, notice it starts up here and it says y equals ax plus b. In this case, a is the slope and b is the y-intercept. So our equation, and we're going to round these decimals, y will equal, let's just go 2 decimal places, 0.94x, and then minus 0.11. And then we're going to write the equation again. And we're going to write it in terms of the meaning of these variables. Because your input, your x values, was quiz 1, and the y values, or list 2, was quiz 2. So we're going to write it again, and we're going to say quiz 2 is equal to 0.94 times quiz 1 minus 0.11. We have just created a mathematical model where you input your quiz 1 score, do the math, and it's going to output your quiz 2 score. Okay, it's a mathematical model. Now, if we go to interpret what these numbers mean, and on your assignment, it was either yesterday or the day before, I think it was 2 days, it asks you to interpret your rate of change and your y-intercept. So let's do the same thing here, because this equation now has meaning. This is the good math, when what you have has meaning. Like, if I just give you y equals 3x plus 5 and tell you to graph it, it's like, who cares, really? I mean, I care, but only because I want to see if you know how to graph it.
I don't.
But the goodness of all this math is when we can start to see how it is modeling something. So this negative 0.11, the y-intercept, is what happens when quiz 1 is 0. If you were to get a 0 on quiz 1, our equation predicts you're going to get a negative 11% or a negative 0.11. Whatever, I don't remember what the units were. Were those just quiz scores or percent? Yeah. So, okay, what that tells me is like that doesn't make sense. So this model, if we were going to actually use it, we would probably have to come up with the domain that we think it applies to. And if you look at your smallest first score, the smallest first score was like 11, right? So we might have a domain that says this model only applies if you score between like 10 and whatever. Because getting a 0 doesn't even make sense. Now this slope, remember that slope is the change in y over the change in x, which in this case is going to be the change in quiz 2 over the change in quiz 1. And that is, if I make it a fraction, 0.94 over 1. So what our slope is telling us is that quiz 2 will increase by 0.94 points for every additional point that you get on quiz 1. Quiz 2, the score will increase on average by 0.94, so almost a point for every 1 point that you get on quiz 1. So if you get a 23 compared to a 24, it's your quiz 2 score is going to go up by about 1. Okay. Now, these two numbers here, let me explain to you the impact of these. First, go to the R value. R is called the correlation coefficient. The correlation. Correlation coefficient. It tells us the strength of the linear relationship. So if you have, I'm going to give you some different scatter plots here. If you just have like complete randomness, you would get an R value close to 0, saying the strength of your linear relationship is not there. Okay? If you get a scatter plot that like is not completely linear, but you can almost see somewhat of a trend, you might get an R value maybe of 0.6. If you have a linear trend, but the slope of it is negative, then your R value might be negative 0.5. If you have a perfect linear trend with positive slope, R will be 1. And if you have a perfect linear trend, but the slope is negative, what will R be? There you go. So that 0.97 is telling us that this is pretty good. This is not bad to get almost 0.98. That it's not perfect, but it's still a pretty strong linear relationship. I love this number. This number amazes me. And if every stats book didn't tell me what this number really means, I wouldn't believe it. Okay? You guys ready for this?
Yes.
If you take this number and change it into a percent, so about 96%, that 96% tells us what percent of quiz 2 is due to how you scored on quiz 1. 96% of this score depends on how you did on quiz 1. The other 4% are due to other variables. Maybe how long you studied. Maybe what math class you had. I don't know what other variables there are. Isn't that crazy? Like, I don't believe it. No, I'm telling you, like, I
That's
can't
real.
even tell you. If every stats book did not tell me that that was true, I wouldn't believe it. It was when I started teaching stats, it was one of the hardest things for me to comprehend that this number, which literally is this number squared. That's what it is. When it says R squared, it means that they took this number here and they squared it. But that number tells us what percent of Y is due to X.
That's weird.
It is. It's crazy. Okay. Let's try another one. Let's go to number 2. And we are going to go ahead and go through the same process again. I'm going to get you started, but I'm going to try to let you go more on your own. First thing though,
Gotta clear our Medusa.
we got to clear our list.
Yeah.
So where do we go to clear our
Go
list?
to
Second.
Joker. One.
your
Wait,
R.
one, yeah.
Second
Enter.
plus sign.
Yeah.
Second plus sign. Oh, I just didn't show you something I needed to show you. So you can't do it now? We'll have to do it on the next one.
All right.
That's okay. We don't have to get everything in one problem. So we're gonna clear all lists. Now we're ready to go put stuff in our list. So where do I go to put stuff in my list?
Yeah.
Stat and edit.
I did.
And let's put these numbers in.
So we got
Yeah. Nope.
and I take 7. Yeah, that one. And then I got a zoom. I got a zoom stat. Boom! I got a little Dottie boys.
Yep. Do a zoom 9. Remember, always when you want to graph, zoom 9, because that will zoom it to what's on your list. Zoom 9.
He's looking at me. He's hitting the back of the head. What that say? It says,
Okay, so if you've made it to the scatter plot and you're ready to do your regression line, we're going to do stat, calculate, number 4. And let's just make sure we all get to that line, and then I'm going to show you something new.
Heck yeah, brother.
So you have a second stat.
So go ahead, once you get to your equation, go ahead and write it down like we did before. Write it just in slope-intercept form, and then also write it in terms of what X and Y actually represent.
Yeah. like an iPhone score. I got it like this.
Second,
Yeah.
and then hit number 2.
Like that. And just like it's
Hey, now notice our R value is not as high as the last one.
Because it's
So
not
this isn't quite as good of a linear model as the last one was. It's still pretty strong though. Notice that R squared is around 79%, I guess I should round up. 79%. So that's telling us that 79%, let's see, 8 students were asked to estimate their score on a 10-point quiz. They're estimated and actual scores are given. So the X values were what they predicted, and actual scores is the Y, the output. So this says that 79% of their actual score was due to what they predicted. And the other percent was due, the other what, 11%? 21% was due to something else. Okay? Now, the thing is, when you predict your score, you kind of know if you've been doing anything. Like, you have information. You have inside information on your education. So, okay, now I want to show you the next thing. I want to show you how we can go graph this prediction line, because that's what it is. It's a prediction line. How we can graph it over the top of our scatter plot. We could just go type it in, like you could estimate it, but there's a way that you can type it in exactly. And I want to show you that. So go to y equals. Don't do anything yet. Let me remember where I'm going. So just ignore me for like 10 seconds. Okay. I'm there. Okay, here we go. You guys ready? Half of you aren't. The half that's not ready has so the other half can figure this out.
Okay.
Okay, so we're going to go to y equals, and then I'm going to go to VARS, bars, VARS. It's right here next to clear, bars, VARS, bars. I know that's why I'm spelling it. VARS, bars. I don't know how else to say it. Bars. No, I'm saying that because stats always bar, VARS, bars. Now go to number 5. Hey, stop talking unless you have a question. I really don't need. I just need you to listen. But if you have a question, then I want to hear from you. But we don't need just chatter like while we're doing something. Quit chattering. We're going to go to number 4. That's what I'm talking about. Stop. There's nothing asked me yet. Okay? Well, there isn't. Like, wait till there's something to ask me. We're going to go to statistics. Number 5. And then we're going to arrow over to equation, EQ, equation. Equation. Okay, I'm going to start over in case you got lost in there. I went to bars. I went to statistics. And I arrowed over to equation. And number 1 says regression equation. Every time you do the stat and then you pick one of those regression equations and you compute it. Now you have to compute it. It will save that regression equation here. It can only save one at a time. But when I hit number 1 now, it's going to go type that. I wasn't in y equals. Darn it. I need to be in y equals, bars, statistics, equation, regression. It types the whole thing in, all the decimals. And now if you hit graph, it will graph that line over the top of your scatter plot.
I have a question.
Yes.
I click that and it
It's probably okay. Let's it just shows so many decimals, it looks like a mess. You go equation, arrow right to equation.
I want new ones.
So it's just like essentially
Yes. Now, this is called a linear regression line. When you guys would plot something by hand and then you fit a line to it, you just try to fit it, that's called a line of best fit. But when you use statistical software and you literally, it finds the best line. It actually, what it is doing is it's taking every single one of these points and it is calculating what we call a residual. A residual is how much error there is. How much error there is. What the distance is from that point to this regression line. And it is finding the line that gives us the smallest amount of residual. So it's like calculate. It's like really, if you had to do it by hand this way and calculate all of it, it would take us forever. But the software will do it for us. So this one, for example, has what we would call a positive residual. The error is positive. This one has a negative residual. So, okay, when do we get out of here? 27. Yes.
You're drawing a hand, Josie? Obviously, you want to do that outside.
Okay, can you guys see for me? Can you go look at 13 and 14? And I just want you to do the same thing. I want you to find the regression equation, and I want you to write it down just like we did, but also write down R and R squared so we can talk about those tomorrow. Because then we can look at them based on what they really were. So 13 and 14 is what you need to do. And I'm not going to do them. I'm just going to let you do them.
Nice.
So to clear up
Nope, that's fine.